James Dwight Dana, the man who gave minerals their order. In the middle of the 19th century, one American scientist quietly laid down an intellectual framework that would influence generations of geologists, miners, and collectors across the globe. James Dwight Dana developed a system for classifying minerals that brought a sense of order to the bewildering array of crystals, metals, and minerals found in the earth. Dana was born in Utica, New York, in 1813, a time when science education in America lagged behind Europe's great universities and institutions. From a young age, he gravitated toward rocks and chemistry, interests that carried him to Yale College. There he studied under Benjamin Silliman, 1779 to 1864, a pioneering geologist and teacher. Yale, in those days, was one of the few American institutions where a serious student of natural science could find guidance. Dana quickly proved himself to be among the brightest. After graduating in 1833, Dana accepted a post as a civilian instructor for midshipmen aboard the USS Delaware in the Mediterranean. But his life changed dramatically when he joined the U.S. exploring expedition of 1838 to 1842. This ambitious voyage, commanded by Lieutenant Charles Wilkes, 1798 to 1877, sent ships around the Pacific and into the Antarctic in search of scientific knowledge and new territory. Dana's role was to document geology and mineralogy, and he threw himself into the task. He hiked volcanoes in Hawaii, studied coral reefs in the South Pacific, and filled trunks with mineral specimens. His reports from the expedition cemented his reputation as one of America's first great geologists. It was during and after these travels that Dana's mind turned toward a problem that had stymied naturalists for centuries: how to arrange minerals in a logical, coherent way. Until then, minerals had often been grouped by their outward appearance, including color and hardness. This was useful for collectors, but limited for science. Dana believed minerals should be classified according to their chemical composition and internal structure, in a system that reflected their true nature. In 1837, while still in his 20s, Dana published the first edition of A System of Mineralogy. It was a bold work, both comprehensive and clear. Rather than focusing on superficial traits, Dana divided minerals into groups based on their chemistry. In doing so, he gave miners, students, and scientists a common language. His categories made sense not only in the laboratory but also in the field. There, a working geologist could apply Dana's framework to real samples pulled from the earth. Over time, Dana's system evolved, but the main classes he introduced remained remarkably stable. At its heart, his classification divided minerals into broad families that reflected their chemical skeletons. A new system. Dana's classification begins with the native elements, the simplest substances found in nature in their pure form. Gold and silver gleam alongside graphite and diamond, minerals prized not only for their beauty but also for the way they reveal nature's basic building blocks. For miners and prospectors, these were immediately recognizable and economically valuable. The halides follow, minerals formed from a metal and a halogen, like rock salt, halite, and fluorite with its luminous cubes. Though less glamorous than gold or silver, these minerals were essential in daily life and industry, quietly shaping economies and communities alike. Oxides and hydroxides, including hematite, magnetite, and bauxite, provide the metals that built the skeletons of cities and machines. Dana recognized them not just for their chemical identity, but for the practical role they played in human progress. Dana recognized that certain minerals, carbonates, nitrates, and borates, shared a common chemical backbone built around similar radicals. By linking them together, he highlighted how chemistry, not mere color or hardness, could reveal deeper connections in the Earth's materials. Calcite, the best known of these, stood at the center of the group, shaping landscapes as limestone and marble and serving human needs from construction to agriculture. Sulfates come next, represented by gypsum and barite. Their importance might not be immediately obvious, but these minerals find use in construction, plaster, and industry, quietly supporting human endeavors. The largest and most complex family is the silicates: quartz, feldspar, mica. These minerals make up much of the Earth's crust. Dana treated them as a single, expansive group, recognizing their overwhelming diversity. He did not attempt to subdivide them by atomic structure. Such insights would only come decades later with X-ray crystallography. But he understood that some organizational framework was necessary. To read more, visit American Essence.